All right, so before we start the parallel lines cut by a transversal, let's make sure you know what parallel lines are, although I'm sure that you do. Okay, so parallel lines would be, if I used these pencils or pens to represent lines, parallel lines would be, you know, like this, kind of go in the same direction, but they're also in the same plane. So when I say plane, visualize a piece of paper. Could a piece of paper contain these two lines? If I did it like this, sure. Would they still, if I tilted it like this, like this, like this? Okay, so parallel lines have to be in the same plane, okay, like that. But if I did this, are they still parallel? Yeah, if you visualize they go on forever, they're still parallel. Now, if I do this, they don't intersect, but they're also still not, they're not parallel, are they? So you know what parallel lines look like. Okay, so just because they don't intersect, parallel lines don't intersect, but just the fact that they don't intersect doesn't make them parallel, okay? Because these lines don't intersect either. It's the fact that they don't intersect, but they're on the same plane, okay? Parallel lines won't intersect, but they're on the same plane. You don't have to know that definition, just recognize parallel lines. Okay, this though, if I have one line that goes like this, and one line that goes like this, they're on different planes. We'd call those skew, S-K-E-W, skew lines. They're all screwed up. All right, so again, not real formal, I don't really care. Parallel lines using like a cube to look at it. So line AE would be parallel to line BF. Now the symbol, how do you write that? Two parallel lines like that. That's the symbol for parallel. And you will need to recognize what that means in the future, okay? Now while I'm at it, because I think you guys can remember it anyway, even though it's not really part of today's lesson, perpendicular lines, lines that make a right angle, okay? The symbol for perpendicular would be this, an upside down T. So if I say line AE is parallel to line BF, okay, that's parallel, but line AE, I should have put the line symbol above it, okay, line AE is perpendicular to, what's a line that it would be perpendicular to? AB is one. What's another one? There's more than one up there. Line AE is perpendicular to AB. What else is it perpendicular to? Yeah, EF, and AE is also perpendicular to EF. And there's one more that I think somebody already said. What else is it is this line perpendicular to? Oh, there's two more. Yeah, it's perpendicular to EH, and it's perpendicular to AD. Okay, so anyway, just learning the symbols. This means parallel, this means perpendicular. And we're not even going to be using this one today. I just thought I'd do it while I've got it. All right, so what we're going to do today, well, there's more, skew lines, blah, blah, blah. All right, what we're going to do today is honestly common sense, okay? Now, don't write this down. I don't care if you write it down. Just think. All right, first of all, this says that these two lines are parallel. If they are parallel, then they're going to form a whole bunch of congruent angles. And you can use your common sense to see which ones look the same. Okay? Let's start with what you know. Ignore this bottom one. By the way, two parallel lines cut by another line like this. This line is called a transversal, if you see that word. Again, it's not so much that you have to memorize it. You just need to recognize it if you see it in the future. This guy right here is called a transversal. All right, so let's go with what you already know. If I ignore this bottom line and I just deal with this up here, then you already know the measure of all four of these angles, because that's just intersecting lines forming vertical angles. We did that yesterday and the day before, right? So this angle here, which is 50, and this one here that I'm pointing to, what are they called, first of all, everyone? Vertical. And if this is 50, then this is 50. Okay. Now, use the fact that you have straight lines. Cover up this bottom and look just at these two angles. They form a line. So they are a linear pair, and they're also supplementary. So these two that form a line, they have to add up to 180. So what would that make this guy up here, everyone? 130. Okay. And if this is 130, then these two are vertical. So this one would also be 130. All right, that's all stuff you already know. Nothing new there. All right, but now the common sense part. If this line L2 is parallel to L1, that means the tilt of it is the same as the tilt of this one. So doesn't it seem reasonable that if this one's slanted the same as this one, but this is the same line up here as it is down here, then doesn't it just seem like common sense that all four of these angles are going to be the same as all four of those? Right? Duh. So this angle up here, that's 50, and this angle here, they're both going to be 50 because they're tilted the same, they're slanted the same, they're parallel, and they're both using a parallel line in the transversal, the same transversal. Does that just make common sense? Okay, so if that's 50, fill in the other ones. That means this is 50, and the other two are 130. Easy, right? Okay, so what I find is that everybody gets this problem super duper easy when I leave it just numbers, but when I throw in algebra, people are confused. Okay. But with geometry, the first step is the geometry and the rest is algebra. You know your geometry. So this is going to seem silly, but the thing that people mess up is recognizing when you write your equation, because you're going to have x's and stuff in here, when you write your equation, are the two angles that I point to, are they equal or do they add to 180? Okay, so these two angles right here, if this was algebra, these two, you would set them equal. But these two, you would say, add up to 180. So I'm going to point to equations right now, or I'm going to point to angles, and I basically just want you to tell me, are they equal or do they add to 180? Okay, so I'm going to skip ahead in my PowerPoint real quick. I want to get to the algebra ones. There's a whole bunch of vocabulary I still have to teach you, but I don't feel like doing it quite yet. It's boring. Okay, so here we go. We'll do one together first. So as always, there's two angles. I gotta solve for x in order to find the angle. I didn't even write the directions up there. It's kind of assumed. So all you gotta do to know how to begin is figure out, are the two angles the same, in which case you write that they're equal, or are they different, in which case they form a line and you'd say they add up to 180. So in this case, these two angles, this guy and this guy, are they equal or do they add to 180? Those are your choices. Yell it out, equal or 180? Equal. So just write that they're equal. 2x plus 14 equals 3x plus 2. Okay, solve that for x. And then take your value of x and plug it back in to see if I wrote a decent problem or if it doesn't make sense. Is my picture drawn to scale? I have no idea. Oh no, I thought you raised your hand. You found x?
Yeah.
Did you also plug it back in?
Yeah.
Okay, if you subtract 2x on both sides, which you'd never have to show, you can just do it. You could also at the same time subtract 2. Okay, hopefully you're getting better with your quickly solving equations. Then subtract 2 on both sides. Did you all get that x is 12? Okay, X is not a degree. It's just a placeholder for a number that will tell you the degree. So now taking that 12 and plugging it in right here and plugging it in right here, okay? 3 times 12 would be 36. Add 2 and you'd get 38 degrees is the angle. Did I draw a 38 degree angle? Not so much, but we'll go with it. All right, if this is 38, then this one should be 38 as well, but let's plug it in to be sure. Plugging in that X is 12. 2 times 12 would be 24. 24 plus 14, does it check? 38. Easy? Okay, so now one more. How about if they're way apart from each other? Now, can you still tell the relationship when they're not next to each other? Okay. Some people are way more visual than others. Some people can totally see, and some people look clueless. I think it's a visual learning type people, okay? So here's what I would do for you if you cannot tell. First of all, looking at this angle right here, would you say that this angle is acute or obtuse? It is what? Acute. This one up here, is it acute or obtuse? Obtuse. Therefore, are they equal? No. So therefore, if they're not equal in this scenario, then they have to add up to 180. The other thing you could do, if it helped, is you could say this angle is the same as this angle. Okay, you could rewrite it here, and now they're next to each other so you can see they form a line. Okay, but honestly, no matter what, two angles, any two angles in this picture, any two angles are either going to be equal or add to 180. So if you can visualize it and see that one is little and one is big, then they're not equal. Okay, so are we clear that on this one your equation should be that the two angles add up to 180? Okay. Listen to the calculators opening. Come on, people. Try to use those itty-bitty brains. I know you can do it. Let's see if I can do it. I'm probably talking crap and I can't even. Let's see. You should be able to use your brains. Maybe. Oh. Go. Solve it. She switched over on you?
Yeah, because in my Spanish class, and when you did a Zoom, she was on the Zoom and she was on.
That doesn't necessarily mean that she switched, though. She might just have be absent. You don't know for sure, right?
It's been a long time.
I'll look. Either way, I can look. Thank you. Yeah, here's the thing that happens, unfortunately, is you could be sitting next to somebody who tested positive, and if you're sitting this close, even with masks on, then if you're sitting next to somebody for more than 15 minutes at a time, you're quarantined even if you're not sick. So people end up getting quarantined for 2 weeks at a time, feeling absolutely fine. So that's why I've been recording, just in case it happens to someone. So it doesn't mean that they necessarily switch to e-learning. They might just be stuck at home, or they might be sick. There's no telling, really. But I can look it up. All right, so first of all, I want to make sure you added like terms because these x's were on the same side. So 7x and 3x is 10x. Fingers crossed. Please tell me you did your math right on this one. This is a negative 22. The sign goes with the number behind it. So this is a negative 22 and a positive 2. When the signs are different, you actually subtract and keep the sign of the bigger number. Did you, without a calculator, say that that was negative 20? Yay, yay, yay. Okay, good. All right, so from here, it's the same old, same old. I know you know what to do. Add 20 to both sides, and you get 10x equals what, 200? Divide by 10 on both sides, and x is, say what? 20. And plug it in. Yes, this is definitely not a calculator question, slackers. Don't just assume you need that calculator. It's like your little pacifier, you have to have it. If x is 20, I'm going to plug it in here, and I'm going to plug it in here. We can definitely do this. All right, if we plug it in here, 3 times 20 is 60, add 2 and you get 62 degrees. Try to remember the difference between a random placeholder and a degree. This was an angle. Plugging in the 20 up here may be a little more difficult. 7 times 20 is 140. Subtract 22 and you get 118. And then degrees. And then how are these two angles supposed to be related? They're supposed to add up to 180. And you can do the quick check. This is 118, this is 118. This is going to have to be 62 and 62. This is 62, this is 62. This is the situation that you should be visualizing in your mind every time. These 4 angles are always going to be the same as these 4 angles. Okay? If the lines are parallel like this. All right, so now